simplifying square roots and cube roots. So simplifying square roots, that's what you did in Algebra 1. Simplifying cube roots, that's going to be something new for Algebra 2. Now, when you're simplifying square roots, you have to use perfect squares. So what is 1 squared? 2 squared. 4, 3 squared. 9, 4 squared. 16, 5 squared. 25, 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 100. And that's usually about as far as we go out with our perfect squares. And when we were doing our factoring, when we factored the special cases, in order for a variable to be a perfect square, the exponent had to be even, like x to the second, x to the fourth, x to the sixth. I'll just put dot, dot, dot. Keeps going. So today we're going to be using those perfect squares to simplify these square roots. So look at number 1. You should automatically know the answer for number 1. What's the square root of 49? 7. But for number 2, do you know the answer? What's the square root of 24? If you put 4.8, it's going to be wrong. So we're going to simplify these by factoring the number. So if you have a 24, we're going to factor the 24, but we want to use the largest perfect square that's a factor of 24. Well, it's obviously not going to be 25 through these because they're too big, because they're bigger than 24. So it's going to be one of these 3. So out of these 3, which one of those is the factor of 24? 4. So instead of 24, we're going to use 4 times 6. Because what is 4 times 6? 24. Now I'm going to mark out the 4 because what's the square root of 4? 2. And so when I simplify that, after you take the square root, it comes out. So the 2 comes out front, and what's left on the inside? 6. So you did this back in Algebra 1. You did a little tiny bit of it in geometry as well, those of you who've had geometry. So 2 square root of 6 is the answer. Next one, problem 3. We have the square root of 18. Now, is 18 a perfect square? No. We need to find the largest perfect square that's a factor of 18. Yeah, if I look at my list of perfect squares, it's not going to be 25 or larger. The only perfect square I could use would be 4, 9, or 16. And which one of those is a factor of 18? 9. So I'm going to use 9 times 2. Put the perfect square first. And when I take the square root of 9, so mark out the 9, what's the square root of 9? 3. So 3 comes out. And what stays on the inside? 2. So the answer is 3 square root of 2. Next one, number 4. We have the square root of 128. Is 128 a perfect square? No. So you need to find the largest perfect square for 128. And what's the largest perfect square for 128? 64. 64 times what? 2. Now, is 4 a factor of 128? Will 4 go into 128? Yes. But is 4 the largest perfect square? No. So you want to make sure you're using the largest perfect square. Oh, not 64 times 4. It's supposed to be 64 times 2. 64 times 2. Now mark out this 64 and square root it. So what's the square root of 64? 8. So 8 comes out front. And what's left on the inside? 2. So the answer is 8 square root of 2. Number 5. Now this one has a value out front. So keep the 5 out front. Now we need to break up the 72. So what is the largest perfect square for 72? 36. So use 36 times 2. Now mark out the 36 and square root it. What's the square root of 36? 6. Now when you write your final answer, these outside numbers get multiplied. So what is 5 times 6? So this would be 30 square root of 2. Number 6, now we have a variable. So if you take the square root of a variable, you just cut it in half. So what's half of 6? So the answer is just x cubed. Next one. Again, when you're taking the square root of a variable, just cut it in half. So what's half of 2? So I mark it out, and a to the first comes out. What's half of b to the 8th? B to the 4th. So our answer is just a, b to the 4th. So when you cut it in half, that's the square root, it comes out. It no longer stays on the inside. Number 8, now we have the square root of 7. Can I cut that in half? No, not easily. So what we have to do is we're going to have to factor this as well. So what I want you to do with it is break it down and bump it down a degree. So that's x to the 7th. If I bump it down 1, this needs to be x to the 6th. So x to the 6th times x to the 1st gives me x to the 7th. So use the even exponent right below it. So right below 7 we have 6. Now mark this one out because I can take the square root of it because it's even. And what's the square root of x to the 6th? X to the 3rd, x cubed. So when I write my answer, it's going to be x cubed square root of x. Number 9. Notice, are these exponents even? No. So bump it down a degree. So a to the 3rd needs to be a to the 2nd times a to the 1st. And how do I break up b to the 7th? B to the 6th times b. Now the even exponents, I can square root them. So mark out the a squared. What's the square root of a squared? A. Mark out b to the 6th. What's the square root of b to the 6th? B cubed. So what goes out front? AB cubed. What's left on the inside? AB. So anytime the exponent is odd, you'll have that variable left on the inside. So for A, 3 is odd, so we'll have an A left on the inside. And for the B, 7 is odd, so we'll have a B left on the inside. And number 10. Now this time we have both a coefficient and a variable. So now we're combining the two together. So for 28, I need to break it up using a perfect square. So what's the largest perfect square for 28? 4. So 4 times what gives you 28? 7. And then for x to the 11th, how do I split that up? X to the 10th times x to the 1st. Now mark out the 4. What's the square root of 4? 2. Mark out the x to the 10th. What's the square root of x to the 10th? X to the 5th. So what goes out front? 2x to the 5th. What's left on the inside? 7x. So 2x to the 5th out front, 7x left on the inside. Okay, number 11. I want you to do 11. We'll check your answer in a moment. Make sure you're using the largest perfect square. largest perfect square for 32? 16. If you use 4, that wasn't the largest one. So 16 times 2, 8 to the 4th is good because it's even. But how do you break up b to the 9th? b to the 8th times b to the 1st. Mark out this 16. What's the square root of 16? 4. Mark out a to the 4th. What's the square root of a to the 4th? A squared. Mark out b to the 8th. What's the square root of b to the 8th? b to the 4th. So this would be 4a squared, b to the 4th. What's left on the inside? 2b. Next one, number 12. If you have numbers out front, just bring it down. Now 36. Do I have to break up 36? No, it's already a perfect square. So if it's a perfect square, leave it alone. But x to the 7th, how do I break that up? X to the 6th times x times y. Mark out the 36. What's the square root of 36? 6. Mark out x to the 6th. What's the square root of x to the 6th? X cubed. Now, what do I do with all these outside numbers? Multiply. So multiply the coefficients first. What's negative 3 times 6? Negative 18. And when you multiply your x's, x to the 3rd times x to the 3rd is x to the 6. When you multiply, add those exponents. So 3 plus 3 gave us 6. And what's left under the radical? X, y. Okay, that was simplifying square roots. Now on the back, what do you notice? If you don't have a back, then you'll need to copy these down. Okay, now the first thing. All of these are going to be cube roots. From 13 through 24 is going to be cube roots. So we need to know our perfect cubes. So 1 to the 3rd power is, what's 1 to the 3rd power? 1. What's 2 to the 3rd power? 8. 3 to the 3rd power? 27. 4 to the 3rd power? 64. 5 to the 3rd power? 125. And then variables are perfect cubes if their exponents are multiples of 3, like x to the 3rd, x to the 6th, x to the 9th, x to the 12th. Keeps going. Now go ahead and copy down problem 13. Number 13, the cube root of 8. 8's a perfect cube. What number to the 3rd power equals 8? 2. Number 14 is the cube root of negative 27. Cube root of negative 27. Well, what's the cube root of 27? 3, but it needs to be negative 3. Because what's negative 3 to the 3rd power? Negative 27. Okay, go ahead and copy down number 15. We have the cube root of 108. Cube root of 108. Now, is 108 a perfect cube? No. So we'll have to use one of those perfect cubes. So out of that list, what is the largest perfect cube that's a factor of 108? Does 27 go into that? Yes, 27 times 4? There we go. So put the cube first, so 27 times 4. Then mark out the 27. I can take the cube root of 27. What's the cube root of 27? 3. So my answer, 3, comes out front. Make sure you put a cube root, so make sure you have the 3 inside this little radical hook right here. And what number's left over on the inside? Of 4. So 3 cube root of 4. So it's very similar to what we just did with the perfect squares, except these, we're going to have perfect cubes for our factors. Next one, 625. So cube root of 625. Yeah, 125 times 5. Mark out the 125. What's the cube root of 125? 5. So how do I write my answer? 5 cube root of 5. So 5 out front, 5 on the inside. Number 17, we need to find a cube root or a perfect cube for 56. So this is 7 cube root of 56. So 7 cube root of 56. So bring down the 7, bring down the cube root. We need a perfect cube for 56. What's a perfect cube that's a factor of 56? 8. 8 times what? 7. Then mark out the 8, because what's the cube root of 8? 2. And what do I do with my outside numbers? And what's 7 times 2? So this would be 14 cube root. What's left on the inside? 7. Number 18, we have the cube root of x to the 12th. Cube root of x to the 12th. Now that one's already a perfect cube. How do I know that's a perfect cube? It's a multiple of 3. So how do you take the cube root of a multiple of 3? Divide by 3. So that exponent needs to be divided by 3. So what's 12 divided by 3? 4. So the answer is just x to the 4th. Next one, we have the cube root. Under the cube root, we have a to the 3rd, b to the 6th. So a to the 3rd, b to the 6th. Now, are those perfect cubes? Yes. How do you know those are perfect cubes? They're multiples of 3. So mark out the a to the 3rd. What's the cube root of a to the 3rd? A. Mark out b to the 6th. What's the cube root of b to the 6th? B squared. So our answer is just a, b squared. What's left on the inside? Nothing. So it's just ab squared. Number 20, we have the cube root of x to the 5th. So cube root of x to the 5th. Is x to the 5th a perfect cube? No. So we need a perfect cube to break up the x to the 5th. So what do you have to have in order to have a perfect cube for your variables? Multiple of 3. Well, you find the multiple of 3 right below your number. So what multiple of 3 is below 5? 3. So this would be the cube root of x to the 3rd times x to the 2. Because what's 3 plus 2? 5. So you need a multiple of 3 below your value. So 3 is below 5, and 3 is a multiple of 3. Now mark out your x to the 3rd. What's the cube root of x to the 3rd? X. So what's our answer? 3. X cube root of x squared. Make sure with these cube roots, make sure you have this little 3 right there in the radical symbol hook thing. Okay, 4 more to go. Number 11, we have the cube root of a to the 11th, b to the 8th. Cube root of a to the 11th, b to the 8th. Are those perfect cubes? No. How do I know they're not perfect cubes? They're not multiples of 3. So I need a multiple of 3 that's below 11. 9. So this would be a to the 9th times what? A to the 2nd. And for the b, what's multiple of 3 is below 8? 6. So this would be b to the 6th times b to the 2nd. Now mark out the a to the 9th. What's the cube root of a to the 9th? A cubed. Mark out b to the 6th. What's the cube root of b to the 6th? B squared. So this would be a cubed, b squared, cube root, and what's left under the cube root? A squared, b squared. Number 22, we have the cube root of negative 192, x to the 7th. Cube root of negative 192, x to the 7th. Now, if it has a negative, that just means your answer is going to be negative. But if it's a negative, I want you to go ahead and pull out negative 1 as one of your factors. So pull out the negative 1. And then for 192, we need a perfect cube for 192. 64 times 3. And for x to the 7th, how do I break that up? X to the 6th times x to the 1st. Now mark out the negative 1. What's the cube root of negative 1? Negative 1. Mark out the 64. What's the cube root of 64? 4. Mark out x to the 6th. What's the cube root of x to the 6th? X squared. You divide it by 3. 6 divided by 3 is 2. So that gave us the x squared. Now what do I do with all three of these outside numbers? Multiply them. So it's negative 1 times 4. So that gives us negative 4. And put your x squared behind it. And then we'll have our cube root. And what's left under the cube root? 3x. So if it's a negative, you're going to have a negative as part of the answer out front. Okay, last two. Number 23, we have the cube root of 216, a to the 9th, b to the 13th. I want you to go ahead and do problem 23. You'll have to write it on the back. Now, did you have to break up the 216? No, 216 is a perfect cube. Do you have to break up a to the 9th? No, it's a perfect cube because it's a multiple of 3 for the exponent. Now, b to the 13th, what multiple of 3 is below 13? 12. So we need to have b to the 12th times b to the 1st. Mark out the 216. What's the cube root of 216? 6. Mark out the a to the 9th. What's the cube root of a to the 9th? A to the 3rd. Mark out b to the 12th. What's the cube root of b to the 12th? B to the 4th. So what goes out front? 6a cubed b to the 4th, and then we'll have the cube root, and what's left on the inside? B. Okay, I want you to do 24. For 24, we have negative 6x to the 6 out front. Then we have the cube root. Under the cube root is negative 686 x squared y to the 10th. So you do that last one, problem 24, and we'll check your answers here in a moment. Number 24, we have the negative 6 negative 6 x to the 6 out front, cube root. Now if it's a negative, your first factor needs to be negative 1. Teachers, at this time, please release students for B lunch. Thank you. Now for the 686, what was the perfect cube for 686? 343. So this would be 343 times 2 times, can x squared be split up? No, there's not a multiple of 3 below 2 that I could use. But y to the 10th, how do you split up y to the 10th? Y to the 9th times y to the 1st. Mark out the negative 1. What's the cube root of negative 1? Negative 1. Mark out the 343. What's the cube root of 343? 7. Mark out y to the 9th. What's the cube root of y to the 9th? Y to the 3rd. Now, all of these outside numbers need to be multiplied. Now, what happens when I have a negative times a negative? Becomes a positive. So this would be positive. What's 6 times 1 times 7? 42. Then the x to the 6th. Then the y to the 3rd. And then our cube root. And what's left under the cube root? 2 x squared